Good morning, students. So let's continue with the canning and bottling of fruits and vegetables. In the last class, we have discussed a few aspects on the steps involved in canning. So, and prior to that, we have discussed about what exactly is canning, the importance of canning, so how it is going to increase the shelf life of the fruits and vegetables, and improve the nutritive value of the fruits and vegetables. And we have seen how the cans are being prepared. So they are being prepared by using OTS cans. We have seen what are open top sanitary cans, right? And we also discussed about the various steps involved uh, in processing of these particular uh, cans, like the first step being the preparation of fruits and vegetables. So how they need to be washed, the preliminary steps, and the fruits which and the raw material selection, so which involves different maturity stages for different fruits and vegetables, and what are the chemicals that are need to be used, like potassium permanganate or chlorine, or different grading and sorting techniques, so to sort out the fruits and vegetables for canning. And also we also seen so different methods of peeling, coring and pitting. So different methods of peeling, so by using hand, by using machines, or by using chemicals like lye, or by using even heat. So we have seen all these things in the previous class, so in which where we have seen that um, prevention of browning. What exactly is browning? So when a fruit or a vegetable, just like in the case of your potato or brinjal or apple, so when the cut surface is being exposed to atmospheric oxygen, after a certain period of time you will see brown coloration. So that brown coloration is due to the enzyme polyphenol oxidase, so which is catalyzed in the presence of oxygen. So this uh, enzyme will be denatured or prevented by blanching technique. But in certain delicate fruits, like apple or peach, cherry, apricot, or grapes, so it's not used. In such cases, we use chemical treatments like sulfur dioxide, so by fumigation or by dipping in 2000 to 4000 ppm sulfur dioxide for 2 to 5 minutes. This will serve the purpose. So or also this enzyme will be inactive, or its effect is reduced under low pH, so that is by adding acids like acetic acid or tartaric acid, fumaric or citric acid. So by using 1 to 2% of citric acid will prevent browning reactions or browning of the cut fruits or vegetables. Antioxidants, so just like our ascorbic acid, are also proved to have uh, reduced the formation of quinones, especially in the case of kiwi fruits. And also using certain sugars, by using sugars will also help in excluding air, so it forms a coat or a cover, so that it will make uh, oxygen unavailable to the canned fruits or vegetables, so that there won't be direct contact between the enzyme and the oxygen, so for its activity for the formation of brown coloration, as so is the case with in the case of by using salt. So if you would use a salt concentration of 1 to 2% in peeled or cut vegetables, it's going to prevent enzymatic browning. After preparation of fruits or vegetables by washing, cleaning, peeling and blanching, so now they are ready to be filled into the cans. So prior to filling the prepared fruits or vegetables into the cans need to be washed and sterilized. So they are washed for removal of the dirt or dust, so by using hot water or jets of steam. So once they are thoroughly cleaned,
Then they are sterilized by dipping them in hot water or by passing through a steam sterilization tunnel, so they will be sterilized and free from any microbial organisms. So once the cans are thoroughly washed and sterilized, now they are ready to be filled with the prepared fruits and vegetables. So these prepared fruits and vegetables are filled into these cans. We usually use plain cans for the non-colored fruits, but for the colored fruits like plums or black grapes or strawberries, we use lacquered cans. So we fill these cans with either whole fruits, or we can half the fruits, or slice the fruits, or even you can make it into bits and pieces according to the consumer requirements.
Once the fruits or vegetables are filled into the washed and sterilized cans, next step is syruping or brining. If it is a fruit, we use a sugar syrup to concentration of 35 to 55%. If it is a vegetable, so we use a hot brine of 2 to 10%. What exactly is the reason for syruping or brining? So once you place a cut fruit or a vegetable or a sliced one or a whole fruit, you will find lot of interspaces. So these interspaces will be left like that. So whenever you are processing, so that is subjecting it to heating or sterilizing in a sealed container, so there is entrapped air, and for even heating of the contents or even processing of the contents, heat needs to be transferred so within the food pieces. And even so for filling the gaps or filling the interspaces, so as you can see in the slide, so when you place a cut fruit or a vegetable or a whole fruits or vegetables inside a can or a jar, so you will see certain interspaces, so that needs to be filled now with either brine or by syrup, so that it will help in transfer of heat for improving the flavor, and even for filling the gaps between them. So while syruping or brining, so make sure the temperature at which it is done, it is around 79 to 82 degrees Celsius. So leaving a head space. The head space is nothing but the space between the top margin, top end of the syrup to the lid. So that is 0.32 to 0.47 centimeters is the head space that needs to be followed. After filling the cans with fruits or vegetables or with syrup or brine, during the process there may be entrapped air in the can. So that air is the enemy of the entire process. This entrapped air is the source of microbial growth, or its source of spoilage, or its source of can bursting or damaging or formation of pinholes, or even it has the tendency of loss of vitamin C, because the presence of oxygen or entrapped air has devastating devastating effects on the stored food material in the can. So this entrapped air, if it is removed by using this particular step, that is called as exhaustion or exhaustion. So this is nothing but removal of air or excluding the air from the can is called as exhaustion. So this exhaustion will help to create an environment which is free from oxygen, so that the microbes will not grow, and also it will help in preventing formation of small pinholes, so which will eventually cause damage. So this oxygen will also cause oxidation of vitamin C, which is available in the fruits abundantly. So the qualitative and the spoilage aspects will be reduced drastically. Apart from qualitative and spoilage aspects, even the filling of the cans is also will be damaged. So in some of the fruits or vegetables, so some of them they will expand, so during heating process some of them will shrivel during the process of heating. So just like in the case of your beans or peas, so the contents or the can contents will expand, or in the case of your strawberries, uh, the strawberries will shrivel in when they are placed in syrups. So that can be reduced by removing this oxygen. Not only this, so this removal of oxygen will prevent excessive undue pressure, so while processing, because under high pressure the oxygen molecules, so the air molecules will vibrate and will yield lot of pressure, in internal pressure in the can, which will cause bursting of the cans during processing. So this particular slide will give a brief glimpse on if the can is not properly exhausted. In the first picture, if you see, there is an entrapped air in the can. So if the same can is subjected to can of the processing, so you can see the energy gained by these air molecules. And in the third picture you can see that these air molecules have gained the pace and they start exerting pressure on the walls, especially on the lid. So in the third picture it is evident, quite evident, that this can is going to burst. But it's not the case in the case of a bottled um, fruit or a vegetable. So bottled fruit or a vegetable has got a provision through which this entrapped air can escape, so during the process of heating, during the process of sterilization. So that you can see in the picture number 4. There are three methods of exhaustion or exhausting removal of entrapped air from the cans. So one is by uh, hot water, another one is by using steam, the third one is by creating vacuum. So in the first method, by using hot water, uh, you're going to allow these cans to pass through hot water, so at a temperature of around 82 to 87 degrees Celsius over a moving belt. As you can see in this picture, that the cans will be traveling in the conveyor belt, so in a hot water. So this hot water will be up to the level of to the cans, so where the top is exposed, so up to 1.3 to 2.5 centimeters. So the water level will be 1.3 to 2.5 centimeters below the top of the can, and then it passes through this hot water for a period of around 5 to 25 minutes. So at the end of exhaustion, the center of the can will be having a temperature of around 79 degrees Celsius. So this entire process is carried out by clinching, that is loosely placing the lid on the can or without placing the lid on the can. So when it comes out, so the air is filled or is replaced with the steam, so that the air is removed. Another method of exhausting is by using steam. So in a can which is partially seamed or clinched, so when it is exposed to high steam pressure, or when it is injected with high steam pressure at a temperature of 100 degrees Celsius for a time period of 5 to 8 minutes, so just prior to sealing, so this will heat or replace entrapped air present in the can. So if this particular method is being used along with hot fill, it can effectively remove the oxygen entrapped in this can. we can clearly see the picture wherein which steam is forced into the can. So through the partially seamed can, it is replacing entrapped air in the headspace of the can, and it is an effective method of exhausting. In this particular slide, you will see exhausting cans, so using an exhaust box. So the cans are traveling through an exhaust box, so wherein there is a uh, provision for flow of the steam into the cans. So at the end of the exhaustion box, so the cans are devoid of any air present in them or entrapped air present in them. Another method of exhausting is by mechanical vacuum sealing. So this method involves removal of entrapped air by creating vacuum for a short period of time. So the vacuum is created or is removed by using vacuum. So this vacuum, so it draws entrapped air from the partially seamed lid. So this partially seamed lid is called as clinched one. So the when you place the lid, when it is not completely sealed, so this lid is called as a clinched lid. So this clinched lid allows uh, during mechanical vacuum to remove the entrapped air present in it. After exhausting, the next step is seaming or closing. So this involves two-step operation. The first step being clinching, the second step is sealing. In a double seamed can, what you can see, a completely sealed can on the left side and sealed cross section on the right side. So it is quite visible that so there are two hooks. So one hook which is in a light gray color and another hook which is in dark gray color. So these two hooks, so one is body hook, another one is lid hook or cover hook. In the first step, so that is clinching, so the lid is gently placed over the body hook, so that is called as clinching. In the second step, the cover hook is pressed against the body hook so that they will completely overlap and cause sealing. Between the body hook and the cover hook, so there lies a sealing compound. So after the second step, that is sealing, so this particular compound ensures the complete sealing.
Most cans have two can seams, one at the top and one at the bottom. They don't look that impressive on the outside, so let's cut this can in half and zoom in to see a cross section. As you can see, the can seam is made from two interlocking pieces of metal. The can body is shown in blue and the can cover is shown in red. Now let's see how a can seam is formed. The pieces start out looking like this. At the end of the cover is a section called the cover curl. The end of the body flares out and is called the flange. The first operation seaming roll, or first roller for short, guides the cover curl in between the body and the flange. Then the second operation seaming roll, or second roller, flattens the seam. The finished seam is airtight and strong. And that is how a can seam is formed.
As you can see from this particular video, the first operation involves clinching, where the cover hook is partially closed, and in the second operation the cover hook is completely closed and it's seamed. After sealing the cans by using a double seamer, the next step is mentioning or embossing the date of manufacture, the batch number, and all the details of the manufacturing of this canning, lot number, etc. Is done on the lid. So that is on the second cover, which is just then double seamed or sealed. After sealing the can and then embossing with the product name, date of packing, etc., then the next most important step, so which will prevent the spoilage by microorganisms, is so heat processing. So heat processing or sterilization or pasteurization, heating the sealed can in a retort or in a cooker. So during the process of heating, so the produce is exposed to a particular temperature for a specified time. So depending upon the type of fruit or a vegetable that is being used, so the extent of time or the duration of processing is not to be either over or under. So it is over processing is not to be done or under processing is not to be done. If it is the processing is carried out for a longer periods of time, so there is a tendency of damage or spoilage of the texture, flavor, and the fruits or the vegetables, they may lose their texture, they may become soggy, mushy, soft. They may lose even the flavors and the nutrients present in them, especially the heat labile ones like vitamin C and other nutrients. So if you under process it, that is processing time is less than the supposed time, so then it will not serve the purpose of uh, heating the produce or processing the produce, because it won't kill the microorganisms that are present, especially the bacteria. So the processing is depending upon the nature of the fruit, so or a vegetable. If a commodity is having a low pH or they are acidic in nature, the temperature required is around 100 degrees Celsius. If the commodity is having uh, low acidity, so like most of the vegetables, so the temperature required is around 115 degrees Celsius to 121 degrees Celsius. So that means for acidic fruits and vegetables the temperature is 100 degrees Celsius. For non-acidic fruits or vegetables is around 115 to 121 degree Celsius. So during the entire process, so whatever the specified time of processing is done, so at the end of processing, at the end of heating, the center of the can should reach that specified temperature, so that entire microorganisms, especially the bacteria, gets spoiled or they gets killed because of this entire heat processing. The first method of processing is by using open cookers. So these open cookers are nothing but stainless steel tanks. So underneath there is a provision so to heat water by using perforated pipes, so provided with a false bottom. So these perforated pipes, so they will force out, they will provide hot steam. So this hot steam in turn will heat the water present in the storage tank, that is stainless steel tank. So when this water gets heated to a desired temperature, so maybe 100 degrees Celsius for acidic fruits, for non-acidic fruits around 115 degrees Celsius to 121 degrees Celsius, the water gets heated. So in this heated water, uh, caged, so they will insert or they immerse so stainless steel or GI crates. So these GI or stainless steel crates, so they contain or they hold the sealed cans. So these sealed cans, so they are held in crates. So these crates are immersed into the tanks which you are seeing. So when they are placed in this tanks, hot water tanks, for a specified period, so the processing is done. Next method of processing is by continuous non-agitating cookers. As the name indicates, so these cans, they are allowed to pass through a container of hot water. So these conveyor belts, they keep moving, carrying the cans. So the cans move on the conveyor belts. So on these conveyor belts, the cans are moving, but these conveyor belts are non-agitating type. So that means they won't vibrate. So during the process of heating, so these conveyor belts move into the boiling water. So there it will be traveling for a specified period of time at a specified temperature. So when they are moving in the hot water, they are not being agitated. So those type of cookers are called as continuous non-agitating cookers. Contrast to the previous method of processing, that is continuous non-agitating cookers. So in this particular process, you will observe, you will see that it is a continuous agitating cookers. So similar to the previous one, so the conveyor belts will be carrying the sealed cans on the conveyor belts, and they'll reach to a point where there is hot boiling water. So this during the processing time, so the conveyor belts are allowed to rotate in such a fashion that the contents of the container, the contents of the can are agitated. The contents of the can are agitated so that the time required for the processing is reduced. So in this method, the time of processing is reduced, so by additional involvement of agitation of the internal contents of the can. In all the three previous methods, that are those are like open cookers, continuous non-agitating and continuous agitating cookers. So those are all used for the fruits or vegetables, so which are having a pH range more than 4.5. So that means, so they don't need an extra pressure or extra high temperature, so for processing time, because the microbial load is taken care of, that additional support of acidity. So in the case of your high acid fruits, so that means the low acid fruits so need to be processed at a higher temperature and a higher pressure, so that the processing time is reduced, and there is an effective control of the bacterial load in the cans. So here in the next two methods, so that are your pressurized vessels and vertical retorts, so you will employ high pressure, so that is at around 2 to 3 atmosphere pressure, and so this particular method is used at a temperature of 110 degrees Celsius. So high pressure, and that is 2 to 3 atmosphere, and high temperature is employed for low acid fruits and vegetables. So is it clear? Like for fruits or vegetables which are having low acidity, so those fruits and vegetables need to be processed under high pressure and high temperature, that is at around 110 degrees Celsius and a pressure of 2 to 3 atmospheres. So under this method, so there are different retorts in the pressurized vessels. There are different pressurized retorts. So depending upon the orientation of the retorts, if the retort is horizontally placed, that is called as a horizontal retort. If the retort is vertical, so where the loading is carried out from the top, in the horizontal retorts the loading is carried out sideways, so those are called as horizontal retorts. And the next one is vertical retorts, where loading of the cans, so for processing, is carried out from the top. Depending upon the type of heating media, so whether you are using hot water, or whether you are using steam, or whether you are using hot air, so depending upon the type of media also they vary. So depending upon the type of processing, whether it's a continuous process or a batch process, or either it involves agitating or non-agitating. So there are different types of retorts or cookers, so which will help in the processing of low acidic fruits or vegetables. So most of the times it is vegetables. So in this slide you can see different types of pressurized retorts. So basically all these three are horizontal retorts. So in the horizontal retort, the opening is sideways and you can load um, the cans into using a stainless steel or a GI crate. So these crates are filled with sealed cans and they are loaded into the retort. And another third picture what you can see by using steam. So depending upon the mode of heating, either by steam or hot water or by using hot air, so you can use different modes of heating mechanisms in this type of pressurized vessels. So in this particular slide you can observe the sealed cans. So they are carried on a conveyor on a belt, so wherein the cans are placed in a GI or stainless steel crates. So these crates carry these sealed cans and they are placed in the horizontal retorts. The next last method is vertical stationary retorts. So these retorts are usually used in small scale industries. So as you can see in the slide on the right side of the picture, so these are vertical retorts made of either cast iron. So they are provided with safety mechanisms with a safety wall on the top, and the lid is having a facility of bolts, so where you can close the lid after placing the sealed cans inside the retort. So you can seal it perfectly, airtight seal, so by using this bolted steam tight bolts. So we can monitor the pressure and the temperature, so with an inbuilt pressure gauge and thermometers. So so once the heating or the processing is done, so using these retorts, the excess water can be drained off, the stored water can be drained off by using a drain valve. So as you can see in the left side of the picture, so that is a vertical retort is there, uh, wherein which so you are going to place in the cans, sealed cans, in what you call GI crates or stainless steel crates. So they are lowered into these vertical retorts. So once they are lowered, so they are sealed tightly by using the lids on the top and using bolts, so they are airtight. And if for a specified time and temperature, so they are heated or processed. So the heat is provided underneath with a wall, so wherein which the steam enters, which will further heat the water that is present inside the retort. So this hot water will heat the cans for a specified temperature. So so this is how the processing of this uh, cans is carried out in vertical stationary retorts. So in this particular slide you can see that the processed cans from the stainless steel crates, once they are processed, so they are being lowered into a tank of soft water, so which is pre-treated with the 2% chlorine, so to avoid the bacterial load and yeast load, and also to prevent formation of pinholes. This process of immersing uh, these processed cans into the cold water is called as cooling. There are two main factors that affect sterilization. And the first one is being altitude, the second one being the pH. So now we are going to discuss altitude. Just recall the physics lessons from your plus 1 plus 2. so wherein which you have a formula, your Charles law, Boyle's law, which states that so PV is equal to nRT. So pressure is directly proportional to the temperature. So what exactly happens when you climb up a mountain? So when you're rising above the mean sea level, the pressure, whether it increases or decreases. Basically, so when you're going up above the mountain, the pressure decreases. So that's why mountaineers, when they're climbing up, so they carry oxygen masks, so for supply of air. So similarly, when you are going up above the mountain, so the pressure decreases. When the pressure decreases, the temperature required for boiling of water decreases. So it has been established a fact that so for every 152 meters rise in the altitude above the mean sea level, so the boiling point of water decreases by 1 degree Celsius. So automatically the time required to bring the required temperature is increased by 2 minutes. So are you able to follow? So in this, so for increase, due to the increase in the altitude, the temperature required for boiling is reduced, so thereby the processing time is enhanced. Are you getting my point? So here, as the altitude is increasing and the processing time is also increasing, so that means what we do at the plains takes lesser time and the processing time is more comparatively at a higher altitudes. I hope you got the point. Yeah, so in the case of the pressure required to maintain that particular uh, altitude is also more compared to the plains, so you need a special higher pressure gauges if you are carrying out processing at an altitude more than 305 meters above the mean sea level. Another factor that affects sterilization is pH. So nature of the fruit, so some of the fruits and vegetables, they may be having high acid and some will be having low acid. Some of them will be having a moderate quantity of acid, so that is gives indication of the pH levels. Lower is the acid content, higher is the temperature required for processing. If higher is the acid content, lower is the temperature required for processing. In a way, it shows that low acid foods and medium acid foods, so they are processed at a higher temperature, whereas acidic and highly acidic fruits are processed at a lower temperature. So if you see in this particular slide, so there are low acid foods like most of the vegetables like peas, beans, corn, so they will be processed at 110 degrees Celsius, and even the medium foods having a pH range of 5 to 4.5, just like in the case of meat, vegetable mixtures, soups and sauces, so they are also processed at 110 degrees Celsius. So the low acid and the medium acid foods are processed at a higher temperature 110, but you can come down as you see acidic fruits and highly acidic fruits, so ranging from 4.5 to 3.7 and less than 3.7, so you can see the temperature required for processing is 100 degrees Celsius. So can you make out what is the difference that so there is a difference for 110 degrees Celsius for low acid foods, whereas high acid foods, they are processed at a lower temperature. The major fact is that it is having additional benefit of acid content. So when there is a lower pH or high acid content, the bacteria are unable to thrive. The conditions are not suitable for the bacteria to grow under high acidic conditions. So that's the main reason for reducing the processing temperature in the case of your acidic and highly acidic fruits or vegetables. So now we have come to the fag end of the canning, so that is cooling. Once the cans, sealed cans, are processed at a very high temperature, uh, they need to be taken out of processing and they need to be cooled immediately. So at a temperature of they need the center of the, that is the core of the can, to be brought a temperature of 35 to 40 degrees Celsius. So if it is not done, so because of the processing heat, so it will be continuously be cooking inside the can, so it will cause stack burning. So that means, so when they are stacked in the ambient conditions, so they will be continuously be heated, the contents of the can. If this stack burning or the continuous heating of the uh, contents of the can are allowed without further cooling them, so this will cause a poor quality of the produce. Say like for example your peaches or pears or even the tomatoes. So over a period of time, if they are not cooled properly, so they will become brown, um, soggy, uh, overcooked, or soft or mushy. So even the peas, so then they will be reduced to like a paste, or they will be reduced to a mashed pea stage, so which you may not relish, so for using them as a vegetable. So to avoid that one, so these cans need to be stopped from further cooking or further heating or continuous heating even after they have been processed. So how to cool these cans? So these cans need to be cooled either by immersing the processed cans in cool water, so just by immersing them. So you will see in the next slides where there is a picture of these cans are being immersed in cold water, or you can just spray cool jets of water on these cans, or you can just expose them to cool air or ambient air, or we can allow into the retorts itself cool water, so to cool these cans. But whatever the water that is being used, either steam or water or sprays of water, whatever the water is used, it should be free or poor in microbial load. The microbes should be less, the bacterial load should be, bacterial and the yeast load should be less, so that there won't be any further contamination of these cans. Even the water that is used should be soft water. If you use a salt water or a hard water, so this will form corrosion on the surface of the cans, forming pinholes. So to avoid microbial load, now you need to use 2 ppm chlorinated water, or and you need to use soft water for prevention of the pinholes. So in this particular slide you can see that the processed cans from the stainless steel crates, once they are processed, so they are being lowered into a tank of soft water, so which is pre-treated with the 2% chlorine, so to avoid the bacterial load and yeast load, and also to prevent formation of pinholes. This process of immersing uh, these processed cans into the cold water is called as cooling. The final step of canning is storage of the processed cans. After processing and cooling them by immersing in cold water, by spraying jets of cold water on these processed cans, they need to be completely dried. So while storing them, so there should not be slight trace of moisture or droplet on the surface of these cans. so or else it's going to cause rust or fine form pinholes. So this will be having a corrosive action on the surface of these cans. So these cans needs to be completely dry, so when they are being stored at ambient conditions. So once these cans are completely dry and they are labeled using attractive labels, so depicting colorful pictures of sliced pineapple or cut mangoes or peeled fruits or vegetables like peas or beans, or any kind of colorful pictures mentioning the brand name, etc., on the surface of these cans, and they are packed and stored in wooden crates or in CFB boxes. So whenever they are being stored, so they are stored at a temperature of below 30 degrees Celsius. So at ambient conditions they can be stored, so for a fairly longer period of time, up to 1 year, they can be stored without refrigeration, so without any spoilage. So to avoid this thermophilic bacteria playing into a role, so need to avoid keeping them at a very high temperatures. So that's all about this the entire canning process. Hope you understood the process of storing the foods in cans.